Hello, my name is Sattar. Our project name is Image Encryption using Visual Cryptography, and our group mates are Sahana and Vandana. We are group 15. So the contents are visual cryptography, pixel patterns, encryption or decryption, and also we have a demo. So visual cryptography. Visual cryptography means it allows visual information to be encrypted so that the decrypted information is as a visual image. So to share this image, we have secret sharing method. After that, we use transparencies.
Thank you, Sattar. I'll take over from here. Visual cryptography is a cryptographic technique which allows visual information such as pictures and text to be encrypted in such a way that the decrypted information appears as a visual image. And let's look at how this came into picture. Like in 1994, Moni Neuer and Adi Shamir presented the first method called the secret sharing method. So in this, an image is broken into n different shares. And if an individual has like n minus 1 shares, it's not enough to decrypt and get the original image back. So a similar idea was presented, which is called the transparencies, and it was used to implement one-time pad encryption. So here, one transparency is a share.
Vandana, slide.
So one transparency is shared random pads and the other acts as the ciphertext. So also the tool that we are going to be looking at today will be like crypto tool 2. So let's go into the next slide. And now let's look at the pixel patterns used for the encryption. There are, to encrypt a black and white image, like we would require a black and white pixel. Also, different pixel patterns are needed for the encryption. So here we have some 2x2 pixel patterns. So the first one is the horizontal pattern, and the next one is a vertical pattern, and then we have the diagonal pattern. Next, we look at the white pixel encryption. So to encrypt a pixel using this method, we use a random pixel pattern as the first image and use the same pattern as the second image. So when these are combined, we get the same pattern as a result, because the same images are overlapped, and you get the black. When black is encrypted over black, you just get it as a black pixel. So next we have the black pixel encryption. So in this encryption, we have like 3 different possibilities. So we use a random pattern as image 1, and its inverse as the second image. So when image 1 and image 2 are combined, we get a full black pixel as the result. So as you can see here, we have an image 1 and image 2. When they're like combined together, we get the whole black pixel. And then let's talk about the encryption and decryption here. So from the original image, we divided into 2 different images, that is image 1 and image 2, where one of it is the shared one-time pad and the other is the ciphertext. So it can be an alternate. Image 1 can be a shared one-time pad, or image 2 can be a shared one-time pad at any time. So the shared one-time pad is it's shared between the sender and the receiver. So when image 1 and image 2 is combined, we'll get the decrypted image. So combining images can be done by printing them out on a plastic sheet and overlaying them in perfect alignment to get the decrypted image or the plain image. So as you can see here, the plain image is this. When it's encrypted, we have 2 different images, and when we decrypt it, we get the original image back. And let's go. So similarly, in our example, we just use 2 images, but when an image is encrypted, it can have any number of ciphertext images. And when they're all superposed, we will be getting the decrypted image like this. And then we have the algorithm, a generic algorithm or a flowchart. So when an image is given, like an image is chosen, then it's used for that image is being encrypted. And then there's like the secret key or the shares that are like created, and these are distributed between participants. And once they are all combined or superposed all together, then we'll get the decrypted image, or we'll get the original image. And then now Sahana will take over and give the demo.
Thank you, Mana. Thank you, Sata. So let me share my screen. Vandana, could you please enable the sharing screen option? Yeah. So let me know if you're able to see my screen.
Yes, it's visible.
Okay. Yeah. So to demonstrate visual cryptography, I will be using a particular tool that is called Crypto Tool. And here we get the download option where we can download the stable version, the exe version, or we can download the zip file if I don't want to install a particular software in my system. I can use that as an application and then do the cryptography. So I have already downloaded in my system and I have installed. So let me go launch the application. So this is a crypto tool where we can do multiple ciphertext crypto encryptions, different types of encryption. So we are using this tool for our demonstration purpose for the visual cryptography, where we will consider the image to be encrypted and image to be split into multiple shares. In this demo, we will split into 2 shares. And when we superimpose those particular images, we will see how we get the original image. So here in this cryptography, we have a lot of options to create the process, but for the demo purpose, I will be using an existing template that is called visual cryptography for the image processing. So let me open the visual cryptography. Here you can see this particular template is already encrypting a particular text. And when I try to run this particular image, and when I superimpose this, we will see the original text. We have to carefully superimpose. If there is 1% changes in the superimpose, we will not get the actual image. So you can see now I have superimposed 2 ciphertext. So one above the other, then I'm able to see the original key. So similar way we can do it for the image. Let me take it to the image. Let me stop this particular process. This is a plain text. Now I have to import a file. So let me find a file input, drag it here, give this as an input to the visual cryptography. And let me try to align it. It's okay. Now there is a setting option where I can upload a file here. So I have selected few of the images here. We can choose a baby photo or a dog photo or a car photo, which I want to encrypt. Let us take a Audi car. So I have imported an Audi car, which I want to encrypt. So when I run this, we will see 2 encrypted images. Let me just, yeah. So we can see that 2 cipher images are created, or the ciphertext images are created as a encrypted images. When we give this to an individual users, like without, like if I give this to one end user and this to another end user, they will never get to know what is the original image. But when we superimpose, they will be able to see what was the original information they're supposed to receive it. So another way how it is superimposed, again we will see it in this visual cryptography. So these are the 2 cipher images kept one above, So just I'm trying to overlap or superimpose. We can see a original image getting decrypted. And we can see here, there is a threshold setup we have done, or the default one is 128. This particular encryption uses a threshold between 0 to 255. That is a grayscale. So based on my grayscale threshold, the image will be encrypted. If I give this image to a threshold to 50 and then try to run, you will see a different type of encryption. So you can see that some of the original image is not encrypted as our expectation. So whoever is using visual cryptography, we have to provide a range of threshold. Let me give it is not the exact value. It can be between, sometimes for few images it will be within like 100 to 120 you will get the actual image, and sometimes you have to reach till 200 threshold to encrypt it. So now I gave 120. Let me try to play it again. So if I superimpose, I'll get the original image. So this is one, and the advanced one we can suggest as from our team is that here you can see the two ciphertext is just a plain grayscale, a plain image, but in future we can increase the security by providing another images here. For example, if I take a Audi car as an encryption, and if Maruti 800 and Tesla has come as an output, the end user will never know what was the original car we encrypted. But when they superimpose, then only they'll get to know that the Audi car was encrypted. The Audi car image was encrypted. So this is an advanced version. We can do it in future. So this is the demo for the basic visual encryption, visual cryptography. Thank you